Hi, today we're going to prove triangles using side angle side and side side side, two of our shortcut methods for proving that triangles are congruent. Let's take a look at this slide right here, which you should have in your packet, and if you don't, you can just copy the problem down into your notebook. Look at what we've been given and look at the diagram. We do have triangles that look like they're overlapping. However, if you notice, we're trying to prove triangle ARY congruent to triangle XRB. And those are not overlapping triangles, so I'm not going to pull the triangles apart. We can go right ahead and start writing down our givens. So I'll give you a minute to do that. You can write them together or separate them if you want. And then when you write down your givens, make sure to mark your diagram so you can visually see what parts are given as congruent. Okay, I'm done there. Now, we've used both of our givens, used them and marked them up. Looking back at your diagram, because that's all we have left, let's see what else we can do here. We need to now rely on just the diagram and all of our previously learned theorems, postulates, and definitions. We know we're using just side, 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 and side angle side today. We currently have two pairs of congruent corresponding sides. So we either need to find a third side or an included angle that's congruent. Looking at the triangle, I notice we happen to have a pair of vertical angles, here and here. That's what we're going to go for. We can either use letters or numbers. I'm going to use numbers. I'm going to call this angle 1 and this angle 2. And I'm going to say angle 1 is congruent to angle 2. I'm sure you could give me the reason. Vertical angles are congruent. Now, let's mark up the diagram with this being congruent to this. A little hard to see. Make that look a little nicer. There we go, a little nicer. You can visually see that we have one pair of sides, followed by a pair of angles, followed by another pair of sides. We have side, angle, side. Our triangles are now congruent, and we're up to the proof. Three, we can say triangle ARY is congruent to triangle XRB by, and we can simply write it as, we have a side, an angle, and a side of one triangle, congruent to a side, an angle, and a side of the other triangle. Done. That was a nice, easy, short proof. 3 steps. Let's take a look at another one. Here's example 2. You also have it in your packet. Let's start with writing our givens. We only have 2 givens, and they're not what I call loaded givens. They're just straightforward. There's not a lot to do with both of these givens, except perhaps mark the diagram. AB congruent to CD, BC congruent to DA. There you go. If it helps you put a little list, remember, we're going for either side, 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 or side, angle, side. Well, if you look at the picture, We've said in class that anytime two triangles share a side, almost always we're going to go with reflexive. And these two triangles share BD. If we use the reflexive property, then we'll have side, side, side. So let's go with that. BD is congruent to BD. Reflexive property. I'm going to abbreviate there. And let's mark it. I'm just going to put a little X there. Now we happen to have side, side, side. And we have congruent triangles. We are at the proof. Triangle BAD is congruent to triangle DCB by, we have 3 pairs of sides of one triangle congruent to 3 pairs of sides in the next. Another easy 3-step proof. Let's look at the next example. Put this one away. Let's grab the third one. Here we go. This example has what I call some loaded givens. It's got some givens with information where we can draw conclusions. It has an isosceles triangle with JK congruent to KL. We know isosceles triangles have at least 2 congruent sides. Here it's telling us which sides are congruent, and it's already pre-marked. As for the loaded given, that would be the second one right here. M, the midpoint of JL. I call that loaded because it's not something we're going to be able to mark right away, but it is something that we can draw a conclusion from. Let's go with our givens. We have isosceles. We also have JK congruent to KL, which is marked a little lightly. I'm just going to make the markings look a little more clear. And in the same step, I'm going to write that loaded given, the fact that M is the midpoint of JL. Okay, let's do something with that. If M is the midpoint, what can we conclude? Think of what a midpoint does. A midpoint divides the segment into 2 congruent segments. Therefore, JM will be congruent to ML. Nice conclusion. Reason being, a midpoint, I'm going to write it out, divides a segment, it's a little hard to write on here, into 2 congruent segments. There you go. Look at what we've got so far. We have a side to a side, another side to another side. So our third thing that we need, we either need a third side or we need the included angle. So we have 2 pairs of sides, so we need a third side or we need the included angle. I'm going to let you think for a minute. Take a good look at the entire picture and think of the third piece that we need. This is a great proof because at this point we can branch out into 2 different directions. Some of you might say that in step 3, knowing that base angles, I'm going to put my reason first, base angles of an isosceles triangle are congruent, that would give you that this angle is congruent to this angle, which is angle J, congruent to angle L. That would help us out because once we say that, then we have side, angle, side, congruent to side, angle, side, right there. And in step 4, we'd have our proof, which is that triangle JKM would be congruent to triangle LKM by side angle side congruent to side angle side. But that's not all. That's just one way. The other way would be, take another look at the picture. Looking at the picture, an alternate conclusion for step 3 would be to use the reflexive property of Km being congruent to Km. And I'm going to squeeze that in here. The alternate 3 would be reflexive. Pardon the mess here. Property. And that would give you this side right here congruent to itself. If you did that, notice you'd have a side, side, side congruent to side, side, side. So that would finish up the proof, not by side angle side, but side, side, side. I'm just going to leave it at side, side, side for now because I ran out of room. You see there's two different endings to this proof. If you're comparing with somebody, don't think that you're wrong because they have a different way of solving the proof. You might both be right. Let's take a look at the next one. I think, actually that's all we have on this page. There might be another one on another page. We have, that was 2, 3, so we've got 1, 2, and 3. So recapping what we had here, we ended up with a side angle side proof. Then we had ourselves a side, side, side proof, and a third proof that went one of two ways. So it was nice practice. And you know, I think I'm going to end it here. There are more proofs I can do together, but I'm going to let you finish the packet on your own. I hope this helped with the beginning of triangle proofs using side, 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 and side angle side. I'll see you in class.